The next section in the book talks about calculators in mathematics instruction. NCTM states that calculators can promote higher order thinking and reasoning needed for problem solving in our information and technology-based society, and they can also increase student understanding of and fluency with arithmetic operations. Use of calculators is not usually centered in elementary classrooms, but it can be used in elementary classrooms when the teacher has planned ahead the right conditions for the use of this technology. Ignoring the benefits of calculators by prohibiting them can inhibit student learning. When calculators are allowed to be used in class, it can start conversations about how students can use calculators and what kind of settings, and it can help students expand their abilities about how challenging mathematics can be balanced with their computational skills. For example, students need to know how to solve a problem before they can actually use it. And lastly, students need to be problem solvers to use a calculator. The calculator itself won't solve a problem just because the student is using it. The student needs to know the process and how to get to the answer in order to use a calculator. The next section talks about when to use a calculator. Students should be using a calculator when they are not practicing computational skills. So for example, if students are learning how to multiply or they're adding 3-digit numbers, you should not be using a calculator because the point of the exercise is for them to learn how to do it on their own. But they should have a full access to calculators when they are exploring patterns, conducting investigations, testing conjectures, solving problems, or visualizing solutions. Benefits of using calculators: it helps students develop concepts and enhance problem solving. So maybe students are given a problem where the numbers may be pretty hard to work with, but they can use a calculator and then practice solving problems. Calculators can be used for practicing basic facts. When students are working on practicing their basic facts, maybe they don't have anyone who can help them, they can use a calculator to check their answers at the end of the activity. And then they can see if they have mistakes. If they do, they can go back and try again. Calculators can improve student attitudes and motivations. Just by using calculators, students can be more motivated. Students like using tools and other resources other than the traditional pencil and paper. So this can help them be more engaged in activities. And calculators are commonly used in society, so they will end up using calculators later on in life. So it's okay to let them use it now too, but it just has to be planned. Teacher has to plan ahead so that students use calculators in a way that will benefit them. The next section talks about graphing calculators. So graphing calculators can be handheld, web, or app-based graphing calculators. Students can visualize concepts as they make real-life connections with data. So these calculators are more advanced, and it can help students visually see concepts that may be hard to understand. Seeing expressions, formulas, and graphs leads to a deeper understanding of concepts. So if students are confused, they can use calculators to help them visualize concepts and then avoid them being more confused later on. Graphing calculators should be used at middle school level and up. For example, middle school is usually when students start working on algebra, and algebra contains lots of graphs, so they can use these calculators to help them understand concepts being taught. And the last one is help students explore real mathematics. For example, a teacher may give a student a problem that uses real world numbers, and students can use the calculator to help them make the computations more easily, since the numbers would be more hard to work with, but then they can show they understand the problem by solving the problem using a calculator. And lastly, the chapter talks about portable data collection devices. These devices accept a variety of probes to gather data, such as temperature, light sensors, and motion detectors. Data is then transferred to the graphing calculator for storing. Calculators can create a scatter plot or prepare other analysis based on the data that it collects. And students can connect graphs with real-world events. So students can use these to test maybe theories or conjectures they have, and then it can correct their misconceptions they can have as they were learning the concepts, or maybe it can help students just verify their answers because it produces graphs immediately to help students test and discuss concepts. And the last section in the book talks about appropriate and strategic use of digital tools. So first, these tools, technology tools in the math classroom can be used to help concept instruction. So conceptual instruction using real-world context to illustrate mathematical ideas should fully engage students. When students work using a device, there tends to be little discourse, conjecture, or original ideas. Lack of direct contact with digital tools can hurt student learning. The best strategy is to have 1 or 2 students control the program on a large display screen while the class is engaged in teacher-guided discussions and analysis. Technology should be used by both teacher and students to promote understanding and promote engagement. So when students are learning about a certain concept, the teacher shouldn't just be herself up there teaching them how to do it using the tools. Students should also be engaged in the instruction so that they can try it out for themselves, and then their classmates can help them, maybe if they're lost, or give suggestions about how to solve the problem. So this way everyone's more engaged and students can fully understand the concept. Problem solving. So tools in math can be also used for problem solving. There are many digital tools available for students to solve problems. Problem solving is not the same as solving problems. So solving problem is the goal, but if students are just solving problems, it's not going to help them. Solving problems just includes like working examples through a worksheet. They just work it because they follow a formula, but they don't truly understand what it means to solve a problem. Some great online tools include Thinkport, which is a problem solving through gaming application, and Dreambox, which uses games too, but it tracks student progress aligned with the Common Core standards. So on the right side, I have the pictures of Dreambox and Thinkport, and I also have an image of a sample page of a student who was signed in, and these are the kind of games they have on their page to play to help them practice those concepts they are learning. And the last use for digital tools is for drills and reinforcement. Drill programs are for student practice on skills previously taught. For example, when students want to review multiplication facts, division facts, or basic math facts, these apps are great for that because they practice through direct answers and multiple choice to make sure they understand they remember the material. Many programs are set in gaming formats, which makes it more fun for students to actually learn and practice their math skills. Drill programs evaluate responses immediately, so if they get one wrong, it'll tell them immediately, and they'll have to either retry or they have to go through more practice before they can move on through the level. And a distinguishing feature is how incorrect answers are processed. So as I said before, they can either be marked off wrong and told the answer, or depending on which application is used, some programs make students practice further in detail that concept again before they can move on. And 2 examples of these type of tools are Extra Math and Fast Math. I have 2 pictures there for each one, and then here's a sample page of what Fast Math looks like. So guidelines for selecting and using digital resources for mathematics. So here are some guidelines for using digital content. The first one is that free and open source content should be used whenever possible. So before thinking of buying a program or subscription. It's always good to try out the free and open source ones because there are many really great resources out there that are free. Digital content should contribute to the objective of the lesson or unit. So the technology or digital content in a lesson should not just be used as an add-on to take up more time. It should be used so that students can fully understand concepts being taught and practice further. And the third one is for individual and small group use should have specific instruction for using the resource. So the teacher should plan ahead and provide time for exploring and practice using the digital content before, so that students don't waste time trying to figure out how to work a tool. Combine online activities with offline activities. So when you are using digital content, it shouldn't all just be all digital, because then students won't always have that tool available to them. And teachers should create a management plan for the use of the digital content. So there should be a schedule of how often students can use the tools, or assess the effectiveness of the resource. Maybe a tool seems great, but then once students are using it, it's not really helping them understand the concept. And lastly, determine if tool is effectively meeting the objective of the lesson or unit. Maybe the tool is great, but it's just not working for this lesson. So the teacher needs to determine if it can actually be helpful for students. And next we have how to select appropriate digital content. The most important requirement for selecting digital resources is to be well informed about the content. The teacher should ahead of time research about this tool they want to use and figure out how students are going to be using it and if students can be capable of using it. Teachers should also gather information about the digital resources. This includes maybe reading journals about the resources, reading reviews of other teachers who've used it, or using Teachmatrix, which gives an evaluation of different resources available. Teachers can also just ask other peers about a resource they might be thinking of using, and if the other teacher recommends it, then it's probably a good tool to use. Digital content should be accessible to all students, including those with disabilities. So if maybe only some students can use it, then maybe it's not the best resource. The teacher should find a resource everyone is able to use. Teachers should evaluate resources appropriately. So a teacher can maybe try a 30-day trial with the students, test run it with students. If it works well and students enjoy it, then she should continue using it. But if not, then the teacher can find something else that would be more appropriate. And mathematics content is the most important. Even if a tool is really good and students enjoy it, but if they're not learning the content they should be learning, then it's probably best that the teacher finds another resource that will help students understand math concepts. So the last section of the book talks about mathematical resources on the internet. There's a table on page 139, table 7.2, and it lists 6 categories that should be used to determine if an online resource is good. The table is pretty straightforward, so you guys should have read it through the chapter. It's pretty much, does it make sense? Is it updated? Does it come from a reliable resource, and will it help your students learn? And lastly, some examples of online resources. The book lists are electronic textbooks. These are common, everyone uses them. They're just textbooks that are digital, can be updated, it can be customized for a classroom. We have whiteboards, mobile apps, and pencasting. Evernote, you basically write and it records your writing and audio so that it can be uploaded and reviewed by teachers or other students. And teacher blogs, which are free and open to use for anyone. It's a network of professionals, and people just share advice and resources available to everyone. And that's it on chapter 7.